This is Chapter 6, Periodic Properties, Homework Problem. Number 1. Items of which group in the periodic table have a valence shell electron configuration of Ns2, Np2? N means the principal quantum number. Okay, so let's look at those choices here. You see you have 1A, 2A, 3A, and so on and so forth. Those are Roman numerals. So that's simply as the same as, let's take a look at the copy of this periodic table. Okay, if you look at a copy of periodic table, okay, so you see that's maybe just a little bit. Okay, that should be good. You see, that's 1A, that's a regular number, and then that's the numeral, Roman number 1A, and then just 1. So all are the names of the first group. Okay, so and then you have 2A, or just number 2, or Roman numeral 2A. Okay, so that's 1A, 2A, and then 3A. So be careful, 3A is not, if you use just number 1, 2, 3, 4, 5, 6, so it's not 3 anymore. It's a 13. Why? Because the one on top, that number that's continuous from the main group, also cross the transition groups and main group again. You see, that's why it's 1, 2, 3. Well, 1, 2 are main group, then 3 through 12, that's 10 groups. So those are transition groups. B block, we call that. That's why you see that's 1A, 2A, and here's 3B, 4B, you see. But if we continue use the number, that will be 1, 2, 3, 4, 5, 6, 7, 8, 12, and then group 3A will be 13. Group 4A, 14, 15, 16, 17, and then 18. You got it? So therefore, simply, if you see these are Roman numeral, that simply is equivalent to 1A. All right? So then 2A, 3A, 4A, 5A. Okay? So it just means that. Okay, having said that, now let's go back to this question. Which group? You see, we have a total of 8 groups here. That's just the 8 main group, okay, elements. So it does not include any of those transition blocks. So which group would carry an electron configuration of S2 and P2? Okay? So before we solve that problem, let's do a little bit of review. As a matter of fact, we haven't learned this in class yet, but I just assume for students who already learned this, let's just review the material. Okay, let's start from here. So, okay, electron configuration by group. Okay, so you see, as we just talk about, so that should be 1A, 2A, okay, and then 3A, 4A, 5, 6, 7, 8A. And here should be 1B, 2B, 3B, all the way to 10B. All right? Okay. Now you see for the S electrons, S1 always, all of the elements in group 1A always has an electron configuration of S1. Either 1S1, if this is hydrogen, 1S1, and then lithium, that would be 2S1, 3S1, 4S1, 7S1, and the group 2A should be always S2. You see, this is really easy if you understand this. So that will be, okay, 2S2. Okay, let's take an example. Okay, so this will be 2S, sorry, this will be 2S1, 2S2. Let's take example. This one still doesn't have the, okay, this one should do. Okay, so the first period is not drawn in here instead of moved to here. But anyway, so this is the second period. Okay, so then 2S1 is lithium. Now 2S2 is this beryllium. Okay, so those are the S blocks. That's main group 1A, 2A. And now let's look at the BP blocks. Okay, so the one in green. P1 is always 3A, P2 is always 4A, and then so P6, that should be always group 8A. Okay, so only here in the second period, that will be, for this one, for example, that will be 2P1. For this guy right here, that should be 2P6. And then for this one, that should be, let's say for this one, that should be 6P2. And this one should be 6P5. You see? So, and then if we take a look at here, the P blocks, in this case, the P blocks are those kind of blue. All right? So, okay. 2P1, boron. So 2P4, that's oxygen. You see, you can tin. So we had one question previously, tin. So that's 5S2, and that's 5P2. You see, P2. Okay, so that's the S block. And those are actually the P blocks. Okay, the outermost are the P electrons. Even though the S2 electrons are also considered as the valence electron, but you know the outermost is still the P electrons. And then those are the D blocks. All of the D electrons. So you can only find them in, so you find them right here. All right, okay. So, and here's the F block. So, S, again, that's L, quantum angular momentum quantum number. So for S, it's L equals 1. All right. P, L equals, no, S equals 0, actually, I'm sorry. Yeah, P, L equal 1, and D, let's see. Yeah, so L equals 2, that's the D block. L equals 3, that's F block. Okay? So, and now if you look at this copy, again, it's arranged by electron configuration. So, okay, if you have one electron, that will be 1s1 hydrogen, supposed to be right here, actually. And if you have 2 electrons, that's helium, and then that should be right here. If you have 3, just keep filling. You see, 1s1, 1s2, then 2s1, then 2s2, okay? Then 2p1, 2p2, you see, just keep filling, all right? So because the periodic table is arranged by the increasing number of protons, okay, or atomic number, and that happen to be exactly the same number as the electrons, okay? So now go back to this question. After those review, I'm sure those review are really helpful. Okay, so would have electron configuration of ns2 and p2. We already talked about, okay, so p2, that will be here, all right? So that's 2p2, 3p2, 4p2, and so on and so forth. So therefore, that should be group 4a, okay? So group 4a, that should be the correct answer. Or group 14. So why it is 14? Let me find out my other copy of the periodic table. So let's see which one. Yeah, group 14. You see, that's group 1 if you don't use A and B, that kind of notation. So that's group 1, group 2, 3, 4, 5, 12, 13. Group 3A is 13, 14. So that's what I meant. Okay, that's it for this one.